We'll proceed in vector and commercial calculus. Vector and commercial calculus, very meaningful discussion we are making. It's a kind of history in a sense that how we can go in an energy kind of calculation where we have a vector and we have a direction. We have a vector, we have a direction. If vector is a force, then force into direction is the energy. If vector is velocity, then velocity into surface area is the flux. Someone can go ahead with the energy, something kind of analogous to the energy, some mapping someone can consider here also. Velocity vector dot product with the displacement. Velocity vector dot product with the displacement is the net flux that is coming out of. Okay, the way, so I would reiterate whatever we have done, then we will proceed. If this is force field, if this is force field, against this force, against this force, one item is moving in a circle, one item is moving in a line curve. If this is a force field, if this is a force field, under this force field, as always I say, consider there is an energy source. There is somewhere energy source is there, and because of this, there is a force field. Energy source will have force field. If energy source is powerful, typically magnetic energy source or electric energy source or electromagnetic energy source, they will have electric or magnetic or electromagnetic field around it. If this is the electromagnetic force because of some energy source is kept somewhere, then there is an item that is placed here and it moves from here to here. Force, because of this force, item moved here from here to here. There is a work done involved. If there is a work done involved, means there is energy involved. Who, because of whose energy, whom energy, the item moved from here to here. Item moved from here to here because of the force field. Force field is coming from the energy source. Energy source, indirectly it worked and it lost energy, because of that item moved from here to here. In that sense, force field dot product with the displacement vector is the energy. That energy source lost because item moved from here to here. I always give example like down is the earth, and if I leave this item, it moves from here to here. Okay, if I keep this item here and from my hand, if I push this, if this item is there, from hand if I push it, from hand if I push it, it is moving from one location to other location. I am working. I am working and I am losing energy, equal amount of energy. The item is moving from point A to B. Similarly, if item is moving from point A to B, Earth is losing the energy. Earth's force, this is where is my force? My force is this. The body force is applied through my fingers. Earth gravitational pull is not required that it will touch the item. I have to touch the item to move something. Earth gravitational pull is that much powerful that it does not require any item to touch it. Without touch also, it will have gravitational forces, considering it as like a hand of Earth, and it pulls something. Pull something means it works from one location to other location. Pulls or push in this direction, whatever it is. That is the work done. If from here to here, if something is coming, if something is here, then it has potential energy. If something is here, it has potential energy. Difference in potential energy, that much is the energy involved. That much energy Earth lost, making item move from here. So energy calculation, force vector dot product with the displacement vector. Or if I have a pipe, if I have a kind of, consider there is a river, there is a river flowing, there is a river flowing, and I put this circle, I put this circle inside the river. River is flowing like this. I put this hollow circle inside the river. And from here, I am seeing how much water is coming per second. How much water is coming per second. Okay, if I am able to calculate how much volume of the water coming per second. If I know how much is the volume, consider the volume of the water. Consider the volume of the water that is coming per second from here is x, and the area is y. Then velocity of the water is xy because x is meter cube per second. This area is meter square. Meter cube per second by meter square is meter per second. That is the velocity of the water. Someone can measure quickly, right? Or someone can keep one bag here that is covered, sewed here, and completely emptied, and then he just leave it and measure for 10 seconds exactly, and then take out the bag and see how much water the bag has. Makes sense, right? Take it out and take one big bag and mouth of the bag, sew it here completely airtight, and then hold it and go inside the river. And the way river is flowing, if this is the area, this is area vector. Area vector must be parallel to the in the same direction as the river. Go take inside the river and just leave it. While leaving, make the stopwatch on, and after 1 minute, see how much water this bag is carrying. Take it out and measure the water, and then measure the area, divide it by the water volume by this area. That is the velocity of the water. So if this is the velocity vector and this is area vector, velocity vector into area vector is the net volume coming out of it. This is also called flux. So if velocity vector is in this direction, then little water will come out from here. Velocity vector dot with area, dot product with the area vector. That is the flux. Now question arising is, if velocity vector is not in a straight line, like we have given example. Consider there is a electric, then this is a copper wire, and electric is flowing like this. Because of that, it will create electromagnetic field that is circular. Okay, like circular. That equation is minus yi plus xj divided by x square plus y square into constant. Constant includes the current, amount of the current that is flowing, the speed of the electricity, everything. That is a constant into minus yi plus xj divided by x square plus y square. If this is the wire that is in z direction, this is x axis, this is y axis, this is z axis. If this wire is along z direction, then the circle, it will form a electromagnetic field around it. That is minus yi plus xj by x square plus y square. X square plus y square can be written as r square. R square is a distance from here. R is a distance from here. So r square means if you go the more distance, the magnetic field will decrease by r square. Heavily it will decrease. Nearby it, a strong magnetic field will be there. Less, but it will be circular in this direction, in xy plane. Okay, that is another kind of velocity field. Now, someone can ask, like, if I place a surface like this here, then how much is the flux that is passing out through this? How much is the electromagnetic wave that is passing through it? Means if this area is bigger, then bigger volume of the electromagnetic wave coming out of it. Consider electromagnetic wave as a liquid. I'm not saying water. People consider as a water. Consider it as some liquid, electromagnetic liquid, and that is flowing around it. And then if you place a surface, how much it will cross? Or if you place a cylinder, if you place a if you place a cylindrical region, now this is cylindrical region which has vertical surface also, and there is one more circle that is called cylindrical region. If I place a cylinder here, then along the wall of the cylinder, how much is the flux that is seen against? Or consider there is electromagnetic. This is one kind of energy source I am talking. Another kind of energy source is there is the electric field, and electromagnetic field is all around it. There is one electric charge kept here, and electrical field is all around it. In that sense, if I keep a sphere around it, then how much is the flux coming out of the surface of the sphere? Or if I keep a cylinder, if I keep the charge at in the center of cylinder or at the bottom of the cylinder, then on the through the surface, how much is the electric field that is coming out? It makes sense, right? So if there is a cylinder, this is typically a cylinder. So if there is a, oh, too many atoms in my hand. Okay, if there is a small electric charge is there, this is xy plane, and cylinder is kept on the xy plane like this. This is a hole. This is the wall of the cylinder. If someone has kept the electric charge at the center, this is center somewhere, and it is sent. The base circle is centered at the origin. So that is the origin. If charge is kept there, then how much is the charge that is coming out of the surface? Or if the surface is a if the surface is a kind of a sphere, at the center of this sphere electric charge is kept. How much is the electric how much is the electric wave that is coming out of the center of the surface? Electric wave is like this. Or electric wave is there is a current like this and electric wave is around it. Then if I place one cylinder, then through this surface, how much is coming out of it? That is the flux. Someone can calculate it. Now, what is the magic here? If in the energy calculation for the force into displacement, if force vector, if force vector, if force vector is algebraic vector, force vector is algebraic vector, means force vector is changing. It's not a straight line. It is changing anywhere depending upon the x and y. If I have x, y plane and z is dependent component, x, y plane is independent component. Depending on the x and y, the force vector is changing. If I take this point, then force vector is like this. If I take this point, then force vector is changing. Similarly, the displacement vector is changing. It is not a straight line. The way displacement vector, everywhere it is changing. At this point, this is in this direction. At this point, it is. So if I have force vector as algebraic vector, whose component, vector means which has x component, y component, z component, like 2i plus 3j plus 4k. 2, 3, 4 are the component of the vector. Now, instead of 2i plus 3j plus 4k, it is xi plus yj plus x square plus y square k. Then this is algebraic vector. If there is a algebraic vector, if there is a algebraic vector, force field, and displacement vector is also algebraic vector, then how we can calculate the energy calculation? Force vector dot displacement vector is a net energy. But displacement vector is not constant. It is not a straight line. It is not a numeric vector. In that sense, if it is an algebraic vector, then force vector dot d of position vector is the net energy. If displacement is happening in this curve, take any point as P. If this is centered at the origin, from center, take one vector that is called P vector. From center, take a vector that is called P vector. Okay, if this is the P vector, the differentiation of P vector is the displacement vector tangent at this curve. So force vector dot displacement vector is same as force vector dot d of position vector. Why we are coming into calculus is x into x as per algebra is x square. 3 into 3 as per numerical science is 9, whereas x into x as per the calculus it is x square by 2, not x square, provided one x is dependent upon other x. If this is x-axis and this is y-axis, this x-axis is x and y-axis is y into x, where y is not independent to x, y is a function over x, y is a function over x. Okay, if y is function over x, y is function over x, what is the function? Function is x only. So y into x is nothing but x into x or fx into x or x into x. Y into x, if someone calculate, that is the area of the region what it is found by y curve along the x-axis. If this is x-axis, consider there is a y curve like this. What is the area under the y curve touching the x-axis? That is y into x. But certainly it will not be y into x, because y that is considered as the height. If this x, y is this height, at this x, y is this height, at this x, y is this height. If you connect all the points, it become a y curve, y graph. But y is the height actually. If you multiply y with the x, it will give you the area. But that is a kind of pseudo abstract. Certainly it will not be the area. If you multiply height by width and calculating the area, that has to be a rectangle, not variable. But variable way we can say it is the area. Pseudo code. Y into x is area. But actually it will not be. It will be fx dx. X I have to replace with the dx and y replace with the fx. If y is x, means this is the x-axis. Y equal to x, then this is the line. This is the line, y equal to x. Then it will become x dx. X into x is a pseudocode for the area. Otherwise, it is x dx. The x into x in integral calculus is x squared by 2. Normal, if y and x are completely independent to each other, then y into x is yx. If they are dependent upon each other, then y into x is y dx, not yx. If y is dependent upon x, y into x is y dx. If y is independent of x, then it is y into x. Simple. Similarly, if there is a force field capital F vector and there is a displacement vector, multiplication will not be normal multiplication if there are dependency and independency are coming into the picture, and it is coming into the picture. There is x-axis and there is y-axis there. X and y are there in the algebraic vector. So the net energy is force vector dot d of position vector. D of position vector is nothing but displacement vector only, but we have to go through integral calculus. So force vector dot d of position vector, d of position vector. Position vector is a vector. If I take any point here, then displacement vector is a tangent vector. If I take any point here, the position vector is a vector that connects through the origin. That is position vector. Force vector dot d of position vector is the net energy. Similarly, if if it is centered at the origin, if it is centered at the origin, if it is centered at the origin, and from the origin, if I take any point P here, any point P here from the center, if I draw a line, this is the position vector. Then the flux is velocity vector dot product with the area vector, or velocity vector dot product with d of p. D of p is the magic term that we have invented. Go and search the book. There is nothing called d of p. D of p. Okay. If this is p is surface area vector here. Earlier d of p was the curve position vector. Here it is surface area vector. If I am going for the 3D shape density function, then d of p, d of p, d of p will be volume vector. Volume vector. Here it is surface area vector. Earlier case, it was integral, it was a line vector. Just depend upon what dimension you are taking. But always vector field dot product of d of p will give you the net energy calculation. Amazing, mind blowing. This is something that is a generic that we have invented. It is not available in any of the book. Velocity vector field dot product d of position vector. If someone is calculating flux, then velocity vector dot d of position vector of the surface area. Okay, not only that, we went ahead. d of p, d of p is same as dp by dx into dx. If it is a line curve, dp by dx is nothing but if this is x-axis. I'm reiterating third time. I believe I'm last video also I talked about it. It is thrilling, right? If this is x-axis and this is position vector, This is x-axis. If this is the position vector, if this is x-axis and this is position vector, this is position vector. If this is the point P, then point P will come here. This is x. If I go delta x along x, then there is another point here. This is P1, this is P. This point is x comma y. This point is x plus delta x comma function over x plus delta x. There are 2 points here. dp by dx, if I move one unit along x-axis, how much position vector is changing? dp by dx, that is dp by dx into dx. This is what the net someone has to calculate the energy. Similarly, for the area, d velocity vector dot d of p is the net flux. Velocity vector dot area vector is the net flux. Velocity vector dot d of p, position vector of the area. If I do d of position vector of the area, it will give me the area vector only after the differentiation, as we saw. Velocity vector d of p is same as d of p is same as dp by dxy plane, because there are also two components in 3D. One component is called z-axis and another component is called xy plane, that is independent, and this is dependent. XY plane constitute x-axis and y-axis. That is xy plane, x-axis, y-axis. This is z-axis. I can say there are three components here: x-axis, y-axis, z-axis, where z is dependent upon x and y are independent to each other. Or I can say there are two components only: z-axis and xy plane. Z-axis is dependent upon xy plane. If I think in that fashion, then flux that is coming out of a surface is velocity vector d of position vector. That is same as velocity vector dot d of position. Since position vector represent area vector d of position vector by d of xy plane into d of xy plane. Same way I can write. What is dp of dp by dxy plane? What is dp by dxy plane? That comes as a question. What is dp by dx in two dimensions? dp by dx in two dimensions. If this is x-axis and this is position vector, this is another position vector. Another position vector, this x is x plus delta x. First position vector, this x is x. dp by dx, how much position vector is changing? We are trying to understand if there is a delta x change along x-axis, how much is the curve length is changing. That is the matter of interest here, dp by dx. Similarly, if I have this is centered at the origin, if this is centered at the origin, from the center of it, there is a point P here. If I take one vector here, that is a position vector. Okay, now this sphere is hanging like this. This is xy plane. If it is kept also like this, or it is centered at the origin, the center of this sphere is the origin. Origin is somewhere here, so I have to push it like this, so that half of it will be above the xy plane, half of it will be below the xy plane. If it is centered at the origin, then it will go half will go down the xy plane. In that case, from the origin, if I take out a vector that is point P, then that is position vector dp by dxy plane. dp by dxy plane means xy plane, not dp by dx. If it is dp by dx, how much position vector is changing if there is a unit change in x-axis? dp by dxy plane, if there is a unit area change in xy plane, then how much unit of area change I see, surface area change I see on the curve. Consider this is point P, and around the P, this is the surface area. If this is kept on xy plane, and this point P, if I take down on xy plane, that point is x comma y. That point is x comma y. At point x comma y, if I go little bit and make a 1 unit of area change, then at point P, then there will be, because now take this is point P. Consider this somewhere this is a big, there is a big xy plane, somewhere there is origin. This point is x comma y, and now I made a delta x movement and delta y movement, delta y movement and delta x movement. I have another point here. This is one point and this is another point. Okay, this point is x plus delta x comma y plus delta y. This point is x comma y. If how much area I am changing on the xy plane, delta x into delta y. Okay, now this point if I take here, consider this is very big. Okay, if the x comma y point is p here and another point x plus delta x comma y plus delta y, that correspond to another point p1 here. P here, that is x comma y. P1 here is p1 here is the x plus delta x comma y plus delta y, whatever z is, and here whatever z. So this is x comma y comma z, or x comma y comma fx plus delta x. Then this is x plus delta x comma y plus delta y comma fx plus delta x comma y plus delta y. That is another point. From this point to this point, there is a surface involved. These are two ends of the point. If I go on delta x and delta y distance, new distance covered, then this is the delta x area involved. Exactly for this delta x into delta y region that I increase, like here on the in two dimensional, if you remember, there was a point x and x plus delta. I moved x delta x from point x and position vector moved from here to here. How much curve it maps from this point to this point, delta x point, how much curve it is mapping? Because of delta x movement, this is the displacement move, this is the curve. This curve involves x comma y both. Okay, that's why it is position vector, not y I have taken. Y is the height, but full curve will be x comma y both points. That's why it's a vector. Okay, similarly, on the xy plane, if I have a point here x comma y and new point is x plus delta x comma y plus delta y, I moved delta x and into delta y area. Because of this area, if it goes up, this area goes up, then how much surface area it is mapping? That is the change in the surface area because happened because of the change in the area on the xy plane. How much the change in the area on the xy plane at point x comma y, that is delta x delta y. How much change in the area I see on the surface? Consider the change in the area is delta A. So delta P by delta xy plane is nothing but delta A by delta x into delta y into dxy plane. This is what we have started. So the net flux is velocity vector dot d of position vector. D of position vector becomes dp by dxy plane into dxy plane. Dxy plane denominator becomes delta x delta y. For this delta x delta y, how much the area change we see on the curve area? D area by delta x delta y into dxy plane. What is the area? We are seeing the new area that is coming, that is mapped exactly from this delta x delta y. If this delta x delta y go up, and then how much the surface area it maps? That surface area, that surface area. Now to find the surface, there are two vectors here. One vector is the original vector, that is x comma y comma z, xi plus yj plus zk. There is another vector. So from this point x comma y, if it go up, then it hits point P here. This is the new point x plus delta x comma y plus delta y. If it goes up, it hits another point here P1. Then P is xi plus yj plus zk, and P1 is x plus delta xi plus y plus delta yj plus fx plus delta x comma y plus delta yk, mu z. Okay, between these two points, what is the area covered? To find that, the way to find that is, now take this line. Take this line. This line is, this point is x comma y. This point is x plus delta x comma y. This point is x comma y. This point is x comma y plus delta y. Now along this line, what if this goes up? Then it will touch a line here also, a vector here also, connecting two points. This point, this point x plus delta x comma y. This point go up and touches P. This point go up and touch one another point that is considered, it is called Px. Then P to Px take a vector. Similarly, this this point is x comma y, this point is x comma y plus delta y. It will go up and it will touch a point here called Py. Py, now from P to Py, take a line, that is another vector. This vector, if it goes, it will fall in xz plane. This is tangential at this point. Okay, this vector, what we are saying, this vector x comma y and x plus delta x comma y, if this point go up, then it will make Px. What is Px? X comma x plus delta xi plus y plus fx plus delta x comma yk. What is P? Fx plus xi plus yj plus zk. If I take this Px and P vector, then it becomes delta xi plus fx plus delta x comma y minus fxy k. Similarly, if I take another vector from P to Py, that will be delta yj plus fx comma y plus delta y minus fxyk. Now full is, now these are the two vectors. If this vector, that is delta xi plus fx plus delta x comma y minus fxyk, this vector and this vector, another vector. Now, whatever we have done, consider these are the two vectors. Let's make a cross product of these two vectors. A point connecting P and Px, that one vector, that vector is in xz plane. How you say it is in xz plane? Because it is delta xi plus fx plus delta x comma y minus fxyk. There is no j component. So this vector is the line connecting x comma y and x plus delta x comma y. This line connecting, there is a vector here. 2 point, if I can, that is a vector here that falls in xz plane. Another falls in yz plane. If I take cross product of these two, they will give me the exact area. Okay, cross product of a vector that is in xz plane and cross product of a vector in yz plane will give me the area as per the simple vector terminology of cross product of two orthogonal components, two orthogonal planes. Now, what we are saying now, Pxp vector cross product Pyp vector is the area. Okay, that is the area we are getting because there is a delta x delta y change in xy plane. Makes sense? If there is a delta x delta y change in xy plane, this delta x delta y will go up and it will map one curved area. That change area is Pxp, vector Pxp cross product Pyp. Okay, Pxp is delta xi plus fx plus delta x comma y minus fxyk. Cross product with delta yj plus fx comma y plus delta y minus fxyk divided by delta x delta y. Now delta x keep this side of cross product, delta y keep that side of cross product. It becomes I plus fx plus delta x comma y minus fxy divided by delta x. Fx plus delta x comma y minus fxy divided by delta x is exactly d of fxy by dx. D of fxy is z. It becomes I plus dz by dxk. Cross product with j plus dz by dyk. This is dp by dxy plane. Mind blowing, amazing. If I make 1 unit of area change at point x, at any point x comma y on the xy plane, if I make 1 unit of area change, then that 1 unit of area will go up and it will map a surface area. How much is the change in the surface? How much area it is mapping there? That is the change in the area. If there is a point x comma y there, if I make 1 unit of area change, how much any unit of area change I see in the surface? Surface is also area only. That is that change in the surface area is nothing but di plus dz by dxk cross product with j plus dz by dy k. Now I plus dz by dxk is same as dp by dx. Position vector is xi plus yj plus zk as at x comma y. That is xi plus yj plus zk. If you do dp by dx, it becomes I plus y is gone, dz by dxk only. Fortunately, that becomes dp by dy. So dp by dxy plane is dp by dx cross dp by dy into dxy plane, that is dx dy, delta x delta y or dx dy. So complete area vector is dp by dx cross dp by dy dx dy. This is the area vector. Now velocity vector dot product with the area vector will give someone as the net flux coming out of it. Dx dy, someone has to integrate over a region on xy plane. If it is a sphere, then if we see from top of the sphere, then it will be a circle. Or depend upon the surface, what kind of surface it is. It will be whatever the area it is covered on the xy plane, that area is the limit of this integration of x and y. Integration limit on the xy plane, velocity vector dot product with the area vector, that is dx dy dx dy into in braces dp by dx cross dp by dy. dp by dx cross dp by dy or I plus dz by dx k cross j plus dz by dy k. I cross j becomes k vector. I cross k becomes minus j vector. Okay. Then k cross, okay, I cross j and I cross k. Now k cross I, k cross j becomes minus I vector. K cross k is 0. Then it becomes minus dz by dx minus dz by dx. dz by dx cross j vector, that is minus dz by dx I minus dz by dy j plus a. Why I am giving this much emphasis is we are proceeding in same manner. Force vector dot d of position vector is the net energy. Velocity vector dot d of position vector of area is the flux. Now keep growing. If in artificial intelligence, if discussion is happening for the n dimension vector, here we are in 3D. N dimension vector also, then vector field dot product of d of position vector is again it will give the net energy calculation. This is energy vector and commercial calculus. Vector and energy calculus. Vector field dot product with d of position vector. This is our invention, and this someone can carry through with bigger dimensions also. That's why we are putting this much emphasis on this discussion. So that is the net flux calculation. Let's proceed. Now consider that I have electric charge. Okay, I have electric charge. I have electric charge, and this electric charge has electric field around it. There is an electric current that is flowing through this wire. This is a wire. This is not a wood. Consider this is a copper wire, and electric is current. Because electric is current, there is an electromagnetic field around it. Equation of electromagnetic field is some constant minus yi plus xj divided by x square plus y square. Now there is a cylinder. There is a cylinder that is outside this wire. This wire is passing through a cylinder. This is a cylinder. Through this cylinder, how much is the electric flux that is coming out of? This example is not available anywhere else. This is our example. How much is the electric flux that is coming out of it? There are three ways to calculate it. First is, now we will go with the same equation minus dz by what is the velocity field. Velocity field is constant minus yi plus xj divided by x square plus y square dot product with minus dz by dxi plus minus dz by dyj plus k dx dy. Now if you see the cylinder, if someone sees the cylinder, then this is z, and this is xy plane. Z is independent of x and y. If it is a spherical, then Z is varying like this. Can you see? If it is spherical and this is xy plane, then height is varying like this. So height is dependent upon xy plane. If xy plane, if I go further, then height is decreasing. If I go to, if it's centered at the origin, if I go toward the origin, then height is increasing. So height is variable on the xy plane. If you take cylinder, then height is constant. It is not dependent upon the xy plane somehow. In that sense, cylindrical coordinate is different. So if I go dz by dx, it will not give me much result. Then we can go by what is then we will go by dp. dp is the velocity vector dot product with the dp. P position vector will go in cylindrical coordinate system. dp by, if I see the surface area, this is the radius. This is the radius. This is theta, it is rotating. And this is the height. There are three independent components in cylindrical coordinate system. Radius, theta on the xy plane, and the height, z. So if I go with the dp is same as dp by, here surface area is a variation of theta and z, because r is constant along the surface area, because the surface area, the radius from the center is constant. In that sense, dp by dp is dp by d theta, dp by d theta z plane into d theta z plane as per our principle. That is dp by d theta cross dp by dz, d theta dz. What is dp by d theta cross dp by dz? Okay, what is position vector? xi plus yj plus zk, where x is r cos theta, where this is radius on the xy plane as per the cylindrical coordinate system. So d of r cos theta I plus r sin theta j plus zk by d theta plus cross product with d of r cos theta I plus r sin theta j plus zk divided by dz, d theta dz. If you see the first one, then it becomes r minus sin theta I plus r cos theta j. Okay, another is gone. Cross product with first two gone, d first two gone, and other is zk by dz k. Now minus r sin theta I plus r cos theta j cross product with k. Okay, then I and k cross product is minus j, and j and k cross product is I. Now it will become sin theta, r sin theta, I'm sorry, r cos theta I plus r sin theta j, d theta dz. It will become cos theta I plus r cos theta I plus sin theta j r d theta dz. This is the area vector. Okay, this is the area vector. That is cos theta I plus sin theta j r d theta dz. But it is I and j. It is hybrid. It is still Cartesian. You can see I and j. It is not pure r vector, theta vector, and z vector. That is pure cylindrical coordinate system. Now velocity vector dot product with the d of p or area vector, that is cos theta I plus sin theta j or d theta dz. What is velocity vector here is, that is minus yi plus xj divided by x square plus y square. Minus yi is minus yi is minus r sin theta I plus r cos theta j divided by x square plus y square is r square. R gone, it become 1 by r. Okay, dot product with, now the r dot product whatever it is, r d theta dz, r again gone. So r completely gone. Now it is minus sin theta I plus cos theta j, dot product with cos theta I plus sin theta j, that is minus cos theta sin theta plus cos theta sin theta d theta dz, that is 0. Minus sin theta cos theta plus cos theta sin theta is 0. There is no flux coming out of it. If there is a round, if there is a round electromagnetic field, and if I place a cylinder, then out of this surface nothing is coming out of it because they are in same direction. This flux is this electromagnetic field in same direction of the side of the cylinder. So nothing is coming out of it. Make sense? Okay, now let's take the pure cylindrical coordinate. I would try, I have not seen it. Pure cylindrical coordinate system. Pure cylindrical coordinate system. If I calculate the d theta by dz, I'm sorry, dp, velocity vector dot dp is the area vector. dp is same as dp by d theta cross dp by dz. dp by d theta z plane into d theta z plane. dp by d theta, if someone cracks it very carefully, he is master of Jacobian, he is master of all artificial intelligence. That's why I'm putting this much pressure in vector and commercial calculus. Because commercial will slowly it will turn up into artificial intelligence. Vector and artificial intelligence calculus. This is the future term. Now d of p is dp by d theta z plane into d theta z plane. dp by d theta cross dp by dz. Okay, what is position vector in cylindrical coordinate system? If I take any point P here, this is kept on xy plane, any point P here, what is position vector? Position vector has three components. One is theta component, one is r component, and one is z component as per the cylindrical coordinate system. Theta component is the r component. If I take if I okay, if I take any coordinate system, all the components must be orthogonal to each other. So if this is the r vector, then theta vector is actually represented by the arc. This is our fundamental. The theta component of cylindrical coordinate system is represented by the arc. Okay, so arc is around it and r is around it. R is perpendicular to the arc. You can see if there is any arc in a circle, then radius is exactly perpendicular to the arc and z is perpendicular to the arc. Arc, z and radius, all three are perpendicular to each other. Radius and arc is in xy plane. So certainly both are perpendicular to the z. And r and arc, they are perpendicular. So all three are perpendicular to each other. Now in that sense, the position vector is, if I take theta, then it is r theta vector. It is r theta vector. R theta vector. I'm not saying theta unit vector. Theta vector. If theta is 2 pi, then arc is if theta is 2 pi angle, then full arc is r into 2 pi r. R theta vector is the theta vector. The way we say x, I vector, j vector, k vector in Cartesian coordinate system, it is r theta vector plus r vector plus z vector. This is position vector. This is our principle. dp by d theta will become r theta unit vector. Theta will go away, r theta unit vector. Theta vector can be written as theta magnitude into theta unit vector. R theta unit vector. R gone and z gone. dp by d theta is r theta unit vector. Cross product with dp by dz. First gone, second gone. Last is z vector. That becomes z unit vector after derivation from dz. Now it became r theta unit vector cross product with the z unit vector. If you do cross product theta and z, it becomes r vector, r unit vector. So it is r into r unit vector d theta dr. This is the area vector. If we are talking about hybrid, then it was r cos theta I plus r sin theta j d theta dz. R cos or cos in book you will find cos theta I plus sin theta j r d theta dz. That is the that is the that I'm sorry j, that is the area vector. Now pure Cartesian coordinate, it is r r r unit vector. Simple. R unit vector or r vector. Complete, someone can say r vector. or r magnitude, r unit vector d theta dz. That is the pure. Now let's take this velocity vector. The velocity vector, that is minus yi plus xj, that is r vector. Minus yi plus xj is around a circle, that is r vector. R vector divided by x square plus y square, r square. R vector divided by r square. Dot product with the r vector. Dot product with the r vector. dr d theta. I'm sorry. I'm extremely sorry. Okay, the velocity vector is minus yi plus xj divided by x square plus y square. Minus yi plus xj is round. If this is electrical current, then this is the round that is made, that equation is minus yi plus xj. Direction is in theta arc direction, not r direction. So minus yi plus xj is r theta unit vector. It is in minus yi plus xj. If you take the magnitude, it becomes x square plus y square square root. That is r radius. R magnitude, r theta unit vector, because it is along the arc. R theta unit vector divided by r square, 1 by r. There it is r unit vector d theta dz. R unit vector dot product with the theta unit vector is 0. Theta unit vector, that is around it, and r unit vector, if you do dot product of the orthogonal these two, it is 0. So there is no flux coming out of, but if you see, take the cylindrical coordinate system, it is extremely easy to calculate. This is our invention. Any energy calculation is velocity vector field dot d of position vector. D of position vector, if I took in cylindrical coordinate system, d of position vector is dp by d theta z plane. dp by d theta cross dp by dz d theta dz. That came as r vector d theta dz. Whereas velocity vector, the electromagnetic field, is r vector r theta unit vector, because it is in arc direction, divided by r square. R square, all gone, theta unit vector dot product with r unit vector d theta dr. That dot product itself is 0. So no flux coming out of it. Now someone is free to calculate if there is an electric charge kept. Electric charge kept equation is some constant, and then r vector divided by r to the power 3. That is the electric vector. That is the electric field. Constant, some constant r vector, because electric field will be flow all around the direction. Electric charge r vector divided by r to the power by 3. That is the equation. Now if I take a cylinder around the electric charge, one cylinder, how much electric charge will flow from it? If I take a spherical region, then we calculated it. I believe the electric charge equation is q into r vector divided by r to the power 3. If there is electric charge kept like this, and all around there is a sphere of a radius r, whatever it is, the flux that is coming out of is q into 4 pi. This is what we calculated. Consider this is kept like this, electric charge is kept like this. Instead of big sphere around it, there is a cylinder around it. Now if there is a cylinder around it, and it is at height z, and it is kept at the bottom, cylinder is kept at xy plane, charge is also kept at the xy plane on the origin, and this is centered at the origin. The bottom plane is centered at the origin. If it is kept like this, means this is kept, the charge is kept like this. Charge is kept like this at the origin. This is xy plane. If this is xy plane, this is the origin. Charge is kept like this. And one cylinder is also kept at center at the origin only. It is a big cylinder. Surface is like this. Now radius is r. Now you calculate what is the flux that is coming out of the cylinder from 0 to z height. Radius r. Okay. And then velocity vector of electromagnetic field is q r vector divided by r to the power 3. Whereas this is a cylinder of radius r and height z. What is the flux? Certainly flux will come out, because flux is all around it. In that sense, if there is a cylinder, from the surface flux will pass. How much is the flux coming out of it? So someone can take it as an assignment, and then he can calculate. If you don't mind supporting us, +91 is the India country code 94831600610. We have always stated this. There is nothing interesting than calculus. There is nothing more interesting than mathematics, and certainly nothing more interesting than calculus. +91 is the India country code. 94831600610 is the telephone number.